1.4 on continuity and one-sided limits. A function is continuous at x equals c if there is no interruption in its graph at x equals c. I think that's pretty self-explanatory. If you have a graph that goes on and on and on, and at some specific value of x, the graph does exist there, it's considered continuous at that point. I don't think that's a huge deal. Continuous functions at x equals c conditions. These are the three conditions that need to exist in order for a function to be continuous at some specific x value. So the first thing that needs to be true is that f of c has to be defined. So in other words, if you are trying to figure out is it continuous at an x value of c, then the graph you have to have a value there. So over here I drew you a graph. Graph 1 goes with this right here. These two things do not match. I am showing you here an example of a graph that is not continuous at an x value of c. So if I were to say, look at this graph and tell me what is f of c, you go to that x value of c, you read up to the graph, there's a big old hole in it. There's a hole in it, so it's not defined there. So this graph right here is not continuous at an x value of c. Are you with me? Okay. Situation number 2. If the limit of f of x exists as you approach that x value of c, then that is another condition that has to be true in order for the graph to be considered continuous. This graph right here, graph number 2, is, does the limit of f of x exist there? So here's your x value of c. As I'm coming in from the left, and as I'm coming in from the right, are we approaching the same value? No. So does the limit exist? No. So I gave you an example again of a situation where it does not exist. The graph is not continuous at c. Same thing for number 3. The limit as x approaches c of the function has to be exactly the same as the value of the function at that value of c. So what I mean is this. If I ask you in this graph, if I ask you what is f of c, what is f of c? Well, if you were asking that, you would go to this point right here. That is the value of the function. But if I ask you what is the limit as x approaches c of the function, what are you going to tell me? You're going to tell me it's this value right here, which is not the same as that value right there. This value is this. The other value is right here. So this is an example of a condition that is not met, again, because these two values are not exactly the same. There are two different kinds of discontinuity. Discontinuity. A function is discontinuous at c if it's not continuous at c. I know it's a very generic equation, but that's true. It's not continuous if it's not continuous at c. That's called discontinuity. Two categories of discontinuity. I really want to get through these two today. There's two categories for discontinuity, and they are removable, and non-removable. Do not make these two things harder than they are. They are removable if you can just fix it really quickly. And I know that sounds very generic, but that's exactly what it means. See how this graph right here would almost be continuous? Yeah, can you grab the phone? Would almost be continuous if it just existed right here. Do you see what I'm saying? So if it existed here, that would be a really quick fix to this graph. This situation also, if we could just move that one point down to the corner there, then this graph would be continuous. So these situations would be really easy fixes to the graph. They are called removable discontinuity. These two examples, those are a little bit more complex. They would not be easy fixes because you have got something completely different going on each side of the graph. This would be an example of a limit that what? Does not exist. Same thing over here. An example of a limit that does not exist. Therefore, it cannot be, I put fixed in quotation marks, I mean that very loosely. Like, it's not a really, really easy fix. Yes?
So, can we simplify that and be it's removable from where it exists?
I think so. Remember, I'm new at this, and I hate to say yes, because there might be that one time when it doesn't, and then I will regret saying that. But I think so, okay? All right, and then we will start talking about examples tomorrow, you guys, but these examples are in your notes. I think once I've talked you through the notes before, these examples will make more sense. Maybe not the algebra ones, but the graph ones should make sense. So please use your notes